Two people run the same distance, but only one actually gets anywhere. How? The answer lies in the difference between scalars and vectors. Let's break it down. A scalar quantity is a quantity that has only the magnitude. Scalar quantities do not have the direction. They are represented only by the size of the quantity. For example, distance is equal to 150 kilometers. Distance is a scalar quantity. As noted, it is represented by the magnitude or size of the distance, which is 150 kilometers, but with no direction. Some other common examples of scalar quantities are length, speed, time, mass, volume, and area. A vector quantity is a quantity that has both the magnitude and direction. Vector quantities are represented by both the size and direction of the quantity. For example, displacement is equal to 150 kilometers north. Displacement is a vector quantity. As noted, it is represented by both the size, which is 150 kilometers, and the direction of the quantity, which is north. Some other common examples of vector quantities are velocity, acceleration, weight, gravity, and force. A quick fact, if you're driving at 60 kilometers per hour, that's just speed, a scalar. But if you're heading north at 60 kilometers per hour, that's velocity, a vector. That small detail could mean the difference between getting lost and reaching your destination. How do you add vector quantities? When adding vector quantities, consider both the magnitude and the direction of the quantity. If the vectors are moving in the same direction, add all the vectors. The resultant vector, Vr, is equal to v1 plus v2, where v1 and v2 are individual vectors moving in the same direction. If the vectors are moving in the opposite direction, subtract the vectors. Then, the resultant vector, Vr, is equal to v1 minus v2, where v1 and v2 are individual vectors moving in the opposite direction. Let's see some examples. Find the resultant vector when an object is moved toward the east by 1 Newton and 3 Newton vectors. Both vectors are moving the object in the same direction. Therefore, the resultant vector is v1 plus v2. v1 is equal to 1 Newton and v2 is equal to 3 Newtons. 1 plus 3 gives 4 newtons, so the resultant vector is equal to 4 newtons east. The second example. Find the resultant vector when a 1 Newton vector moves an object toward the east, while a 3 newtons vector moves it toward the west. In this instance, vectors are moving in the opposite direction, so the resultant vector is equal to v1 minus v2. v1 is equal to 1 Newton, and v2 is equal to 3 newtons. 1 minus 3 gives a negative 2. Therefore, the resultant vector is equal to negative 2 newtons east, or 2 newtons west. The last example. An object is acted upon by 3 vectors. 3 newtons and 1 Newton move it toward the east, while 7 Newton moves it toward the west. What is the resultant vector? In this case, the resultant vector is equal to v1 plus v2 minus v3, where v1 and v2 are vectors moving the object toward the east, and v3 a vector moving the object toward the west. Then v1 is equal to 3 newtons, v2 is equal to 1 Newton, and v3 is equal to 7 newtons. This gives negative 3 newtons east, or 3 newtons west. To recap, a scalar quantity is a quantity that has only the magnitude. Common examples of scalar quantities are distance, speed, mass, volume, and area. A vector quantity is a quantity that has both the magnitude and direction. Common examples of vector quantities are displacement, velocity, weight, gravity, and force. Vector quantities can be added. When the vectors are moving in the same direction, the resultant vector, Vr, is equal to v1 plus v2, where v1 and v2 are individual vectors moving in the same direction. When the vectors are moving in the opposite direction, the resultant vector, Vr, is equal to v1 minus v2, where v1 and v2 are individual vectors moving in the opposite direction. So now you know how to distinguish scalar and vector quantities, and even how to add vectors. But here's a question. Can an object be moving but have zero displacement? Think about it, and in the next video, we'll unravel motion like never before. Stay tuned, stay curious.